All right, this is on variability. Variability describes how much the data values in a data set differ from each other. So the first data set on the left shows the data more spread out. So it starts at 1 and goes to 10. The second data set has a low variability. The data points are closer together. They range from 4 to 7. And the last one has no variability because all the data points are the same. They're all the number 6. So no variability, low variability, high variability, widely spread out, closer together, and all the values are the same. Example 1, label each data value depending on its variability as high, low, or none. So if we look at the first one, so here's our data points. This one I would say is high. The second data points, all right, here, and I would say that that is low. And then our third one is high. And lastly, they're all the same number, so none. Which race is more competitive, this year or last year? So this year, the miles per hour range from 40 to 140. Last year, it ranged from 30 to 190. So if we say which one is more competitive this year or last year, we would want to say this year is more competitive because the data points are closer together. So the data is not as widely spread. All right, histograms. Here are two examples of what a symmetric histogram would look like. So we call this a symmetric histogram. And then we have one that goes up, it comes down, it goes up, then comes down. Some of the histograms are what we called not symmetric. They are considered skewed. So there are two types, left skewed, so that's left, or right skewed. So more data is on either end. So right skewed, which we call positive skewness, or left skewed, which is negative. Example 4. Here we can see that the mean heights of students are going to be at the right or the middle because there are more students with those heights. So here's our heights. It's increasing as we progress through the height of the students. And the frequency here represents, if I look at this number right here, this represents students that fall between 127 and 128 centimeters, and there were 8 of them. That's how you read these. So part A, is the height of students skewed right or left, and how do you know? So if we look back at our chart, our data points are skewed negative or to the left. So we say negative or left. And what does this tell you about the heights of the students? It's telling us that there are more students that are taller than shorter. So not too many students over here that are short. More students are tall. This is the tall side, and this would be the short side.